Okay, so we are going to do a video lesson on cumulative frequency. Some parts on this will be hard to do over video, but we'll try our best. So we're going to begin by looking at a data set that represents the number of home runs hit by American League baseball teams last season. So I wrote them below here in frequency table. You can see them here. This is our data set. And what I want us to do is I want to organize this into a frequency table, grouped with grouped data. And let's say I want, let's do 5 groups. Okay, and these groups need to be inclusive, meaning everything has to fall in some group, and non-overlapping. So one team's number of home runs can't belong to 2 of our groups. So we need to go between, let's see, 253, I think, is that the highest? Yes, 253 is the highest, and is 168 the lowest? 147 is the lowest. So we need, so we can kind of aim to go between 145 and 255. Those are kind of nice round numbers that include our total range. So in order to do that, you can subtract the 2 numbers and divide by 5, the number of groups we want, and that will actually give us 22 home runs in each group, starting at 145. So 145, x less than 167. We'll include the upper portions of each interval. You could just as well do the lower. 167 need to be inclusive. 189. Great, so now we count the number that fall in each bin. So how many are between 145 and 167? Let's see, 1, 2, okay, 2 that I saw there, maybe I missed one. Now, 168 to 189, 1, 2, 3, 4, so 4. Now 189 to 211, 1, and we're including 211, so 2, 3, 4, 5. Great, now 211 to 233. 1, 2, 3, 4, and there's just one big hitting team here in the 233 to 255 range. And our frequencies, do they add up to 15? 6, 11, so we've double counted one group. So let's see, because there should be 15 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no, there are 16. Okay, so that works. So that's a good way to double check that you've included everyone. The number of, if you add up all the frequencies, it should match the number of data points. So there we go. And we can represent this visually using a type of graph you may have seen before called a histogram. Now a histogram is a bar graph. On your x-axis, you have kind of your bins. So we're going to start at 145. Go up to 167, 189, these should be evenly spaced. We mark out our boundaries, and on the y-axis is frequency. So between 145 and 167, we have 2. So this, we draw a bar going up to 2. 167 to 189 is double that. We have 4. 189 to 211, we have 5, so we go slightly higher. Then we have 4 again. And our last one, we just have 1. So this will give you a very quick visual of the kind of distribution of your data. Sorry, these two ones should be dead equal across here. They give you a quick visual. As you can see, this is actually kind of what you would expect, because most teams kind of hit around the same, and as you fall off to the edges, you have lower numbers at the high and low ends. One really bad team or two really bad teams and one really good team. So a lot of data falls like this, and we're going to spend a lot of time later in the unit talking about that. The next thing we're going to talk about is cumulative frequency. I'm actually going to add on here. Cumulative frequency. Now, what is cumulative frequency? Cumulative frequency, you basically just add up the frequency columns as you go through. So in the first row, we have how many are less than or equal to 167? Just our original 2. The cumulative frequency in the next row is how many total are less than or equal to 189. So we have the 2 from before and the 4 new ones, which give us 6. So we add on 4. The next cumulative frequency row is how many are less than or equal to 211. So we add 5 more. Then we add this, and 1, we get 16 total. So the last entry should always be the total number of data points you have. And this might not seem totally useful at first, but as we start graphing, we'll find we have quite a bit of use for it. Okay, so let's do that. So I'm going to copy these down 2, 6, 11, 15, 16. I'm just going to copy this. Okay, now what we're going to do is we're going to graph cumulative frequency. In order to do that, we put cumulative frequency on the y-axis, and we put our data, in this case home runs, on the x-axis. Okay? And we're going to do kind of the same thing. Now, when we graph these, in order to represent our whole bin range, we always use the upper range. So what we want to say is, okay, up to 167 home runs, we have 2 teams. So that's 1 point. Up to 189 home runs, we have 6 teams. 2, 4, 6 teams. Up to 211, we now have 11 teams. 8, 10, so 11. This is a rough sketch. Up to 233, we have 15 teams. I'll extend this a little bit. You have 15 teams. And then finally, up to 255, you have all 16 teams. Now we connect these, not line by line. We just try to draw one smooth curve that fits through all of them. Oops. Let me just undo that. Where's undo? Okay, we'll try that again. One smooth curve. Don't worry too much about how you connect them. It's just not straight lines between each point. It's one curve that goes through them all. Now, what is the use of this curve? Well, it's really useful for estimating median, percentile, quartiles. So for instance, what is the median number of home runs hit? Well, if there are 16 teams, the median should go around 8. There should be where 8 teams have gone. It's halfway through the number of teams. And we can see, okay, that falls somewhere between 189 and 211. You could estimate, oh, maybe it's roughly halfway between. So at 200 would be the median. If you want to know what is the, let's see, the 80th percentile, meaning how many teams, what is the cutoff for the top 80% of home run hitting teams, you would multiply 16 by 0.8. You get 12.8, which is somewhere around here. And trace down, you say, okay, it's roughly halfway between 211 and 233, so say 222. Now you can see this is really, really rough to do by hand. And so usually in the IB, they give you the graph, almost always. I've never seen an exception to that. So we're going to do an example. But first, a little bit of vocabulary. We call Q1 the first quartile, and it's 25% of your way through the data. So in a way, that's the median of the data between the first point and the true median. Q3 is the third quartile. We call that the median of the data between the median and the end of the list, so 75% of the way through the data. And the interquartile range is what we call Q3 minus Q1. So that's where 50% of your data lies. It's between where 25% of your data lies and 75% lies. So let's look at an example, and hopefully this will be more clear. So this is a graph. It shows the stride lengths, meaning kind of the distance you take per step, of a group of 17-year-old boys. The first question says, what is the median stride length of the boys measured? Well, we see on our y-axis, we have frequency, cumulative frequency. So all told, when you add up all the number of people, there are 32 of them. So the median will be right on the 16th. So the 16th measurement corresponds to a 30 centimeter stride length. So it's really just a question of tracing on the graph. Okay, now it says, what percentage of boys have a stride length of at least 36 centimeters? Okay, well, 36 centimeters is here. So we have, that corresponds, we can see, to, there are 28 people who have 36 centimeter stride length or less. And actually, we're going to alter this example slightly to be at most 36 centimeters. It's a little bit easier when I'm not here. So we trace up to 36 centimeters. We see 28 people have 36 centimeters or less as their stride length. So 28 out of 36. What is that as a percentage? Let me just enter that in my calculator. It's 77.8%. So these types of graphs just really enable you to quickly estimate the percentages of people above or below certain values. So that's it. Give the homework sheet posted on Haiku under the second statistics lesson, cumulative frequency, a try, and we will take it up next day.